Welcome to chemistry class. Today we are going to learn some important terms for the topic mole and equivalent. Fine. Now here first we have symbol. Symbol is the short sign of the name of an element, usually expressed by the initial letter or initial letter plus another significant letter of an element in English, okay, or Greek or Latin. Okay. So a symbol also stands for one atom and atomic mass of an element. Next is formula. Formula is a term used for a molecule of an element. For example, hydrogen has this formula H2, or a compound like calcium carbonate has the formula CaCO3. Okay, and this formula consists of symbol of constituent elements. For example, here we have calcium, carbon, oxygen. Fine. So here what we have written is CaCO. These are the symbols for the elements. Next, radicals. Radicals or ions are the charged particles formed by the gain or loss of electrons by the constituent atom or atoms. A radical having single atom, for example O2 minus, is called simple radical. Fine. And if consists of two or more atoms like phosphate, this is called compound radical. Okay. And next is the chemical equation. So this chemical equation represents a symbolic representation of true chemical reaction. A balanced chemical equation with suitable stoichiometric coefficients represents for the ratio of number of mole of reactants giving products accordingly. For example, if you have a reaction like this, where barium chloride reacts with sodium phosphate and forms barium phosphate, okay, and sodium chloride. So if I write this equation, this is not balanced. So we need to balance it. We'll place 3 here because of, you can see here 3 barium atoms are present. So 3 BaCl2. So we'll place 2 Na3PO4 because of this phosphate is having twice. So we'll just place here 2 coefficient, and this is NaCl. We are having 1 atom here for Na and for Cl. So we'll just place here 2. Now this becomes the balance equation. So this plus sign on the left hand side, this says about that these two reactants are reacting, and this arrow says that these two reactants after reacting produce the products like these. Okay, so chemical formula on the left of this arrow represents the starting substances called reactant, and the products are shown here on the right hand side of the arrow. So the numbers in front of this formula, these are the coefficients. Okay, and now next we have the molecule and atom. So a molecule is defined as the smallest possible particle of a substance, okay, which has all the properties of that substance and can exist freely in nature. Or a molecule is, you can say, it's a discrete group of atoms bonded together in a specific arrangements. Now what's an atom? An atom is the smallest particle of an element, okay, like protons, electrons, neutrons. These are present, the smallest particles of any element. They can take part in the chemical reaction and they may or may not exist free in the nature. For example, hydrogen is present in the form of molecule and not in the form of the atoms. So next we have is the atomicity. This term atomicity refers for the number of atoms present in one molecule of an element. For example, atomicity of this hydrogen is what? This 2. This is the atomicity. For if you have this O3, atomicity is 3. So what is that? This term represents the number of atoms present in one molecule of an element. Okay, next we have the term mole. Okay, so the term mole, what does it say? Let us understand more about the mole. The term mole was first used by Oswald. Fine. Term mole was first used by Oswald and in the year 1896. The mass in gram of 1 mole of a substance is known as the molar mass. So what is a molar mass? The mass in grams of 1 mole of substance is known as the molar mass of substance, and a mole is defined as the amount of matter that contains as many objects, maybe like atoms, molecules, protons, electrons, whatever objects we are considering as the same number of atoms in exactly the 12 grams of carbon 12. So this number is also known as the Avogadro number. Okay. So it is given by Na, and the Avogadro number is here 6.023 into 10 to the power 23 molecule per mole. This means 1 mole contains these many molecules. Fine. So we can say that 1 mole of any entity contains the Na particles of that entity. Okay. So today we have learned about some significant, some important terms in the moles and equivalent. To learn more chemistry topics and more about these mole and equivalents, just visit, like, share and subscribe chemistry class. Thank you.